ಮ್ಯಾಮ್ ಆಯ್ತು ನೋಡಿ ಮ್ಯಾಮ್, ನೀವು ಕ್ಯಾನ್ ಸುಮಾ ಮ್ಯಾಮ್
ಮಾಡ್ತಿದ್ದೀನಿ.
ಮಾಡ್ತಿದ್ದೀರಾ? ಓಕೆ, ಆಯ್ತಲ್ವಾ?
ಶೇರ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಹಾಗಿದೆ
ಮ್ಯಾಮ್. ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಮಾಡಿದ್ದೀನಿ. ದೇ ಕ್ಯಾನ್ ಜಾಯಿನ್ ಟು ಯೂಟ್ಯೂಬ್ ಆಲ್ಸೋ ಮ್ಯಾಮ್. ಓಕೆ,
ಫೈನ್ ಮ್ಯಾಮ್.
ಓಕೆ ಮ್ಯಾಮ್. ಓಕೆ, ನಾನು ಐ ಆಮ್ ಜಸ್ಟ್ ಲೀವಿಂಗ್ ದ ಮೀಟಿಂಗ್ ಮ್ಯಾಮ್.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಮ್ಯಾಮ್. ಓಕೆ, ಕೇಳಿಸ್ತಿದೆ ಅಲ್ಲ ನಿಮಗೆ?
Yes, ma'am.
Yeah,
Yes,
okay,
ma'am.
fine.
Yes,
Yes.
ma'am.
Yeah. See, 13th one ಅಲ್ಲ? Yes, 13th one. See, the ratios are 1:3:2 ಬಂದಿದೆ ಅಲ್ವಾ? ಈಗ ನೋಡಿ, ಇಲ್ಲಿ ಈ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಈಕ್ವೇಶನ್ ಹೇಗಿರುತ್ತೆ ಅಂದ್ರೆ ಕಂಬಷನ್ ಅಲ್ಲಿ, when you have x as 2, only then your CO2 can be 2 moles. ಕರೆಕ್ಟಾ? ಇಲ್ಲಿ 2 ಇದ್ದಾಗ್ಲೇನೆ 2C ಬರೋದು. ಈಗ ಆಕ್ಸಿಜನ್ ಎಷ್ಟಿದೆ? 6 ಇದೆ. 6 ಇದೆ ಅಂದ್ರೆ 2 2s 4 ಆಯ್ತು. ಇಲ್ಲಿ 2 ಹಾಕೊಂಡ್ರೆ 6 ಆಯ್ತು. ಕರೆಕ್ಟ್. ಸೊ ಹೈಡ್ರೋಜನ್ ಎಷ್ಟಾಯ್ತು ಇಲ್ಲಿ? 2 2s 4 ಆಯ್ತು. ಆಬ್ವಿಯಸ್ಲಿ ಯುವರ್ y is nothing but 4. ಸೊ ಯುವರ್ ಫಾರ್ಮುಲಾ ಕಮ್ಸ್ ಔಟ್ ಟು ಬಿ C2H4. ಅವ್ರು ಹೇಳಿರೋದು 45 ml ಅಂದ್ರೆ 3 moles ಅಂತ. 3 moles ಆಕ್ಸಿಜನ್ ಬರಬೇಕು, 2 moles ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಬರಬೇಕು ಅಂದ್ರೆ ನನ್ನ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಏನಾಗಿರ್ಬೇಕು ಅಂದ್ರೆ C2H4 ಆಗಿರ್ಬೇಕು. ಫೈನ್, ಗಾಟ್ ಇಟ್?
Yes, ma'am.
Yes. D is C2H4. That's it. 14th one. What quantity of ammonium sulfate is necessary for the production of ammonia gas sufficient to neutralize a solution containing 292 gram of HCl? ಈ ಕ್ವೆಶ್ಚನ್ ಪ್ರಾಪರ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು. They're telling to neutralize HCl you require ammonia. ಕರೆಕ್ಟಾ? ಅಂದ್ರೆ ಇಲ್ಲಿ ನಡೀತಾ ಇರೋ ಪ್ರಾಸೆಸ್ ಯಾವುದು ಅಂದ್ರೆ ನ್ಯೂಟ್ರಲೈಸೇಷನ್. ರೈಟ್. ಫಾರ್ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಯು ಹ್ಯಾವ್ ಅ ಫಾರ್ಮುಲಾ N1V1 is equal to N2V2, or normality is nothing but N into molarity where N is your X factor. Right. ಸೊ ಇದನ್ನ A into M ಅಂತ ತಗೊಂಡ್ರೆ A1 M1 V1 is equal to A2 M2 V2 ಅಲ್ವಾ? ಇದು ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಫಾರ್ಮುಲಾ. ಇದು A1 M1 V1 is for your acid and this is for your base. ಅವ್ರು ಕೊಟ್ಟಿರೋ ಆಸಿಡ್ ಯಾವುದು ಅಂದ್ರೆ HCl ಅಂಡ್ ಬೇಸ್ ಯಾವ್ದು ಕೊಟ್ಟಿದ್ದಾರೆ? ಅಮೋನಿಯಾ. ಕರೆಕ್ಟ್. ಫಸ್ಟ್ ಅಮೋನಿಯಾ ಎಷ್ಟು ಬೇಕು ಅಂತ ನಾನು ಕಂಡಿಡ್ಕೊಂಡ್ರೆ ಮಾತ್ರ ವಾಟ್ ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ಅಂತ ನನ್ನ ಕೈಲಿ ಹೇಳಕ್ಕಾಗೋದು. ಕರೆಕ್ಟ್. ಫಾರ್ ದಟ್ ವಾಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ಇಸ್ ಫೈಂಡ್ ದ ಮಾಸ್ ಆಫ್ ಅಮೋನಿಯಾ ರಿಕ್ವೈರ್ಡ್ ಫಸ್ಟ್. ಓಕೆ, ಫಸ್ಟ್ ಅಮೋನಿಯಾ ಮಾಸ್ ಎಷ್ಟು ಬೇಕು ಅಂತ ನಾನು ಕಂಡುಹಿಡ್ಕೊಳ್ತೀನಿ. ಅದನ್ನ ಕಂಡುಹಿಡ್ಕೊಂಡು ವಾಟ್ ಇಸ್ ದ ಕ್ವಾಂಟಿಟಿ ಅಂದ್ರೆ ಮಾಸ್ ಆಫ್ ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್ ಎಷ್ಟು. ಸೊ ಇಂಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ ದಿಸ್ ಇಸ್. ಫಸ್ಟ್ ಐ ನೀಡ್ ಟು ಫೈಂಡ್ ದ ಮಾಸ್ ಆಫ್ ಅಮೋನಿಯಾ ಅಂಡ್ ದೆನ್ ಫೈಂಡ್ ದ ಮಾಸ್ ಆಫ್ ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್, ರೈಟ್? ಯಾಕಂದ್ರೆ ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್ ಇಸ್ ಅ ಸಾಲ್ಟ್, ರೈಟ್? ಆ ಸಾಲ್ಟ್ ನಮಗೆ ಒಂದು ಆಸಿಡ್ ಮತ್ತೆ ಒಂದು ಬೇಸ್ ನ ಕೊಡುತ್ತೆ. ಅದು ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋಣ. ಬಿಫೋರ್ ದಟ್ ದೇ ಆರ್ ಟೆಲಿಂಗ್ ಇಟ್ ಇಸ್ ನ್ಯೂಟ್ರಲೈಸ್ಡ್ ಅಂತ. ಸೊ ನ್ಯೂಟ್ರಲೈಸ್ಡ್ ಅಂತ ಎಲ್ಲೆಲ್ಲ ನಿಮಗೆ ಬರುತ್ತೋ ಮೇಕ್ ಶೋರ್ ಯು ಆರ್ ಯೂಸಿಂಗ್ ದ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಫಾರ್ಮುಲಾ. ಓಕೆ, ಸೊ A1 M1 V1 is equal to A2 M2 V2 is your neutralization formula. ಸೊ HCl ಎಷ್ಟಿದೆ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, 292 grams. ಇವಾಗ ನೋಡಿ, A1 ಅನ್ನೋದು ಎಕ್ಸ್ ಫ್ಯಾಕ್ಟರ್, ಬೆಸಿಸಿಟಿ ಆಫ್ ದ ಆಸಿಡ್. ಬೆಸಿಸಿಟಿ ಎಷ್ಟಿದೆ, ರೀಪ್ಲೇಸಬಲ್ ಹೈಡ್ರೋಜನ್ಸ್ ಎಷ್ಟಿದೆಯೋ ಅದೇ ಅದರದ್ದು ಬೆಸಿಸಿಟಿ, ಕರೆಕ್ಟ್? ಸೊ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ದಿಸ್ ಆಸ್ 1 ಇಂಟು, ನನಗೆ ಗೊತ್ತು ಮೊಲಾರಿಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮ್. ಹಾಗಿದ್ರೆ N ಇಸ್ ಈಕ್ವಲ್ ಟು M ಇಂಟು V ನ, ಈ M ಇಂಟು V ಜಾಗದಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ HCl ಅಂತ ತಗೋಬಹುದಲ್ವಾ, ಕರೆಕ್ಟ್? ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ HCl ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು A2 ಅಂದ್ರೆ ಏನು, ಅಮೋನಿಯಾಗೆ okay, it's a base, it's nothing but monoacidic base. ಒಂದೇ molecule of acid ಜೊತೆನೆ ಅದು ಕಂಬೈನ್ ಆಗಕ್ಕಾಗೋದು. So therefore we are going to write this as 1 into M2 mass into V2 is nothing but the number of moles of base which is nothing but ammonia. ಆಯ್ತಾ? M into V ಜಾಗದಲ್ಲಿ number of moles ಹಾಕೊಳ್ತಿದ್ದೀನಿ. Now the mass of this HCl is given ಎಷ್ಟು, 292 ಅಂದ್ರೆ 292 divided by its molar mass is nothing but the moles, correct? Number of moles is equal to given mass divided by molar mass. So N of HCl ಜಾಗದಲ್ಲಿ given mass is 292 divided by its molar mass is given in the bracket which is 36.5 which is equal to number of moles. mass ನಾನು ಕಂಡುಹಿಡಿಬೇಕು ಎಷ್ಟು ಅಂತ, ಅಮೋನಿಯಾ X ಅಂತ ತಗೊಳ್ತೀನಿ, divided by its molar mass is also given which is 17. Is that correct? We need to find X which is nothing but 292 into 17 divided by 36.5. Can you solve this and tell me? Solve ಮಾಡಿ ಹೇಳ್ತೀರಾ? 292 into ಎಷ್ಟು?
136.
136. Yes,
Six.
yes, 136 grams is the mass of ammonia. Okay.
136.
Yes. Now consider ammonium sulfate. What is the formula for ammonium? Ammonium charges +1, sulfate charges -2. This comes as base 2 here and this comes as base here. So therefore we are going to get NH4 twice SO4. So this is going to give NH3 plus H2SO4. Correct? ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕು. ಸೊ NH4 2 times ಇರೋದ್ರಿಂದ 2NH3 ಬರುತ್ತೆ. Then remaining is only 2 hydrogens. H2 is written here SO4, right? This is balanced. Now I can tell like this, 1 mole of ammonium sulfate is giving me 2 moles of ammonia. Is that correct? Now what is the mass of 1 mole ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, molar mass of ammonium sulfate ಎಷ್ಟು, 132 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So 132 grams is going to produce 2 into 17 grams of ammonia, ಕರೆಕ್ಟಾ? ಹಾಗಿದ್ರೆ 136 grams ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ಇದೆಷ್ಟು ಬೇಕು ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. So can you calculate and tell this? Yes, very simple. ಎಷ್ಟು ಬರ್ತಿದೆ?
528.
Yes, that's the
528.
right answer. Yes, good. That's the right answer. Yes, 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 that's the right answer. You're going to get the same thing. ಬಂದಿದ್ಯಾ?
Yes, ma'am.
Yes.
Yes, ma'am.
See, 100 ಇದೆ. ಇಲ್ಲಿ 17 3s and 51 ಬರುತ್ತೆ. 51 ಅಂದ್ರೆ ಹೋಗಲ್ಲ. So 3 point something ಬರುತ್ತೆ. 3 point whatever it is, 8 or something you're going to get. So 136 into 4 ಅಂತ ಮಾಡಿದ್ರು ಕೂಡ 400 and something ಬರುತ್ತೆ. 36 multiply ಮಾಡಿದ್ರೆ you're going to get 5. ಎಷ್ಟಿದೆ? 528 grams. Yes, that's the right answer. It is option C, 528 grams. Fine. Just understand the concept. What are we doing here is, they have told that neutralization is happening here anta alva. Neutralization between HCl and NH3. Wherever you get the term neutralization, you have to use the neutralization formula, which is N1V1 is equal to N2V2. This is called neutralization formula. Right. I'm writing it in terms of molarity. So A1M1V1 is equal to, because you are used to the term molarity, not normality. Only because of that reason, I have written the normality in terms of molarity. Okay. So A1M1V1 is equal to A2M2V2. A is for acid and B is for base. So you know that M1 into V1 is nothing but M into V, which is equal to the number of moles. Keeping this, I have written in place of M into V as N. Right. So how to write the number of moles in terms of masses? Given mass over the molar mass. I have taken it over the molar mass. And here I don't know what is the mass of ammonia, that I have to calculate X divided by 17. So what you're going to get is 136, you told. And according to the equation, ammonium sulfate is going to give you what? Ammonia and H2SO4. I have taken the balanced equation. From this, I know that 1 mole ammonium sulfate is giving me 2 moles of NH3. Therefore, 132 grams of ammonium sulfate is giving me 34 grams of ammonia. Therefore, 136 grams of ammonia is produced by 528 grams of your ammonium sulfate. Is that clear?
Yes, ma'am.
I have done this in detail because you have to understand what is neutralization. You're not familiar with neutralization, right? For that, I have done it this way. Is that fine? Yes, 15th one we are doing. A solution containing 0.2 mole of ferric chloride. We have ferric chloride. I think this is an easy one. You can do it on your own because we have already done all these in the class, right? So ferric chloride is allowed to react with sodium hydroxide, NaOH. NaOH. So what you're going to get is NaCl plus FeOH thrice. So therefore 3, if I take here, this is also 3 NaCl. Correct. This is the balanced equation. Now, they're telling the number of moles of ferric chloride taken is 0.2 and the number of moles of sodium hydroxide taken is 0.24. Correct. Now I know that 1 mole requires 3 moles to give 3 mole of NaCl and 1 mole of FeOH thrice, right? Now, if I take 0.2, right, how much of this will be utilized? Let me calculate that first and tell which is the limiting reagent, correct? So now can you tell which becomes easier is, yeah, for 0.2,
Mom,
0.2
can
is
you
nothing but,
zoom the written part, mom?
fine. Yes. So 0.2 will require how much is? X is nothing but 0.2 into 3 divided by 1. 0.2 is nothing but 2 by 10. I do this as, okay, directly tell what is 0.2 into 3 is nothing but 0.6. So how much is there? I require only 0.6 moles of NaOH. But how much do I have is 0.24,
Excess reagent, NaOH.
which is
Excess reagent.
less. Correct.
Yes.
So which is less, that becomes
Yes.
the limiting reagent. So 0.6 moles is required, but I have only 0.24 moles. Therefore, limiting reagent is your NaOH and excess reagent is your FeCl3. Correct. So what they have given here is limiting reagent for the reaction is NaOH. It itself is correct, but that is correct. A is correct. But coming to B and C, see how much of FeOH thrice is formed, that we have to find, right? So keeping the limiting reagent, we are going to find 3 moles of NaOH gives 1 moles. Therefore, how much do we have is 0.24 gives how much? So this is 0.24 into 3, which is nothing but, 3s are 12. Point.
2.72.
Yes. Correct. 0.72. That's not there. Right? That's
0.72.
wrong then.
Approx 0.8.
If that is
Approx
wrong,
10.
it's 0.72. If that itself is wrong, then we need not check the other options because it is all of A and B, A, B and C that would be wrong. Correct. Is that correct? So only option is option A. Limiting reagent for this reaction is NaOH. Fine. It is option A. Limiting reagent is NaOH. 16th one.
Excuse me, ma'am.
Yeah, tell me.
It's actually 0.24 by 3. So we get 0.08. It's all of A, B.
Oh, sorry. Just a minute. Let me check this. So 0.24 gives x. X is equal to 0.24 divided by 3. Yeah, you're getting it. 0.08.
8. All of 3 is correct.
0.0, yeah, correct. 0.08 moles
All
of
A, B, C are correct, ma'am.
FeOH thrice. Yeah, since that is also right, you need not check for the third
Check
one.
yours.
Yeah, you can tell all of A, B, and C. Right? Yes, that's the right answer. It is option D. All of A, B, and C. Yeah, 16th one. See, these kind of problems we have done in the class, right? The density of 3 molar solution of NaOH is 1.110 gram per ml, meaning density of solution is given, which is equal to 1.110 gram per ml. And molality is given, which is 3 molar. And the molarity of the solution they're asking, right? Instead of taking this as 3 moles is nothing but 3 molar is nothing but 3 moles in 1 kg of solvent.
3 moles of
Instead of
solution.
doing all that, we have a direct formula. 1 by small m is nothing but your molality, which is equal to density of solution over the molarity of the solution minus the molar mass of solute divided by 1000. If you do this, you get the answer. Can you do this and tell me the answer? So what numericals we have done in the class, no need of solving it that way for CET. You can directly use the formula and solve. Tell the molarity. Okay, you have to tell the molarity for this. Molar mass of solute. What is the solute? NaOH. NaOH is 40. Over 1000, this comes out to be 110 minus 40 m whole divided by 1000 m, which is equal to 1 by 3. Thousand hundred and ten. So this comes out to be 1070. Oh, sorry. 1000 m is equal to 3 into 1110 minus 40 m. So this is 1000 m, that is equal to 3330 minus 120 m. So 1000 minus 120 would be 880. Is equal to 3330.
Ma'am, 2.9
Plus. Wait. 1120 molar is equal to 3330. M is equal to 3330 over 1120. So 00 gets cancelled. 100 and yeah, correct. So 112, right? 100 threesa is 300 and 12 threesa is 36. Approximately 3, meaning 2.9, whatever it is,
2.9.
because it is, yeah, correct. So which option do we
Option
have is, yeah, option A.
A.
Correct. Approximately 3 have written, right? 97 molar is the answer. So I think if you use this formula, that becomes much easier for calculations. Okay. Yes, 17th one. Among the following solutions having the same concentration is, see, we have to find the molarity which is same. Here grams is given. So I take grams divided by molar mass is nothing but the moles. 20 by 40 is 0.5 divided by 200. I'll directly take it in liters, which is nothing but 0.2 liters. Is that correct? So this is 5 by 2, 2.5. This is for option A. For option B, 0.5 mole case. So 0.5 moles is directly given. divided by 0.2, which is nothing but 2.5 again. Next, for option C, we have 40 by 40 is 1 mole divided by 0.1 liters. So this comes out to be 10 molar. And for option D, which is 20 divided by 56. So what is KOH? 39, 19, 16. Yeah, it comes out to be 56. So which is nothing but 20 by 56 into 0.2. Right. So 0.2 liters. So what do we get here is 2 divided by 10. This is 200 divided by 56. So it's approximately 50. Forza is 400, but 3 point something you're going to get. So 3 point, I don't want what is that also. So which has the same molarities? Option A and option B. So what options are there? 192 has the same molarity. Therefore, it is option A. Option A has 192. Right. This is 1. Have taken it to be A and B. This is 1. This is 2. This is 3. And this is 4. So you have it to be option A. Right. Getting this?
Yeah, ma'am. Yeah.
Yeah.
Yes, ma'am.
Yes, ma'am.
18th. 18th. Next, sucrose solution is 1 mole. The mole fraction of sucrose in the aqueous solution is, right? So 1 mole sucrose meaning
1 mole of
1 mole of
1 kg of
sucrose.
solvent.
Yes, in 1 kg is
In
nothing but
1 kg.
1000 grams of solvent. To find the mole fraction of sucrose, I want the number of moles of sucrose divided by number of moles of sucrose plus number of moles of water. Number of moles of sucrose is 1 plus 1000 grams is nothing but how many moles for water? 1000 by 18. 9 is, 5 is 90. So 10 is remaining again 5.5 recurring. So 55.5. Correct. Which is 1 over 56.5. See, you know that 1 over 5 is 0.2. Is it correct? 1 over
Yes,
50 will be
ma'am.
0.02. Correct. If this denominator is greater than 50, your value will come to be less than 0.02. Very close to. Correct. So very close answer is 0.018. Is that fine?
Okay, ma'am.
Yeah. The answer is 0.018. It's the mole fraction. Next, 19th one. Which option is that? A. Have I written the options here? Yeah. 19th one. 10 ml of 0.2 molar HCl and 40. Yeah. 40 ml are mixed together, the molarity of the fine. To find the molarity, you have the formula M1V1 plus M2V2 is equal to M3V3. Okay. So what do you have here? Molarity is 0.2 into 10. I directly write, which is 2 plus M2V2 is 40 into 0.3. So it comes out to be 4
Well,
3 by 10 0 0 gets cancelled 1.2. Right. 12. Yeah, it comes out to be 12. So which is equal to M3 I have to find, and the volume is 40 plus 10, which is 50. So I directly take this 50 onto this side. 14 divided by 50 is your M3. So this is 14 ones are 14 threes are is 42. 3 point something you're going to get. You know that 1 by 3 is nothing but 0.33. Since the value is greater than 3, this value would be less than 0.33, which is 0.28. Fine. Are you understanding what I did?
yes, ma'am.
1 by 3 is nothing but 0.33, but I'm not getting 1.3 exactly here because 14 threes are is 42, 8 is remaining. If I keep point, that becomes a 0, correct? Approximately 5 or something you're going to get. So 0.33 is 1 by 3. 1.35 you have, so your value will decrease from 0.33 to less than that. So less than that, the option is only one, which is 0.28. Fine. 20th one. In the titration of a certain H2SO4 solution, 60 ml of 5 molar NaOH solution was used to come. Just now I told the neutralization formula. Can you tell? What is it, neutralization formula?
V1 is
V2.
equal to V2.
V1 and 1 is equal to V2 and 2.
A2M2 V2 is A1 M1 V1 is equal to A2M2 V2. If this is for acid, this is for base. They're asking the molarity of the acid. So I take the mol M1, which is equal to A2. A2 is base. What base they have given? NaOH. Acid is H2SO4. Okay. So now what is A2? 1. Replaceable OH is only 1. Therefore, it is 1. What is the molarity of the base? 5. And what is the volume of the base? 60. Divided by what is A1? Because for replaceable hydrogens is 2. Therefore, A1 is 2. Into the volume of the acid is given to be 75. Which option has this? 5 into 60 by 2 into 75. Option A. Correct?
Yes, ma'am.
Yes, ma'am.
That's the answer. Fine. So I think you have got an idea of how to use normality, molarity, neutralization formulas and how to find the empirical formula. See, I will give you one clue here. Wherever comes the molecular formula and the empirical formula, you have to make sure that you're finding the number of moles of that particular atoms. If you find the moles of that particular atom, for 1 mole, what is the number of moles of each element present, that becomes the empirical formula. Right? So that's a trick. Like whenever you get the empirical formula and molecular formula, you have to find the number of moles. That's what we did in the problems what we have solved here. Right? So from all the questions, what trick I can give you is, so for empirical formula and molecular formula, you can use this trick only. Find the moles. Whatever data is given, find the moles, you get the answer. This concept we used in that combustion problem, and finding the molecular mass, finding the formula. In all the cases, we have used this trick only. So empirical formula and molecular formula, find the number of moles, right? Find the moles, you get the answer. Next, neutralization formula. Neutralization formula is N1 V1 is equal to N2 V2, or you can take that as A1 M1 V1 is equal to A2 M2 V2. This is the neutralization formula. Okay. So resultant molarity, when they ask you the resultant molarity, you have to take M1 V1 plus M2 V2 is equal to M3 V3. Right? So these are the ones which you have not done in your chapter while solving. So make sure to use this. And one more is normality equals N into molarity. Correct. This N is nothing but N factor, or we call it as X factor also. Are you getting me? Are you getting to me? Hello?
Ma'am, your voice is repeating.
Is it? Okay, just a minute. See, N factor for acid is basicity. N factor for base is acidity. These are the things which you have not learnt in the class in detail. So I'm writing the things which you have learnt in this session, right? So acid base, and for salt, it is cationic charge. And for oxidizing agent and reducing agent, you take the number of electrons change. Right? This is your N factor. Okay. Next, one more formula we have relating molarity and molality. What was that? 1 by small m is equal to density of solution divided by molarity minus molar mass of solute divided by 1000. If you use this formula, you can easily relate molarity with molality. Is that fine? What else what extra thing did we learn in the session? We will summarize all the things. I think only so much we have learned, right? Significant figures and this formula, all that we have learned in the chapter only.
Yes, right.
Yeah. See, this percentage problems we did, right? Like the crystalline salt Na2SO4.hex H2O on heating loses 55.9% of its mass, right? And one more was X4O6, right? So those kind of problems.
Your voice is repeating.
Yeah. So make sure. But if you want, it's repeating. Yes. So make in percentage composition problems. Make sure which element X you need to find. The other element percentage becomes easier for calculation. If X you are finding, take element percentage of other than X. That becomes easier calculation, right? If you take A2O3, finding A, take oxygen ratio, the calculation becomes much easier, right? So these are the tricks what we have learned in today's class. Is that fine?
Yeah, ma'am.
Everybody?
Yes,
Yeah.
yes,
You
miss.
have any other doubts?
No,
Any
ma'am.
other doubts? Clear with all the 20 problems, right?
Yeah, ma'am. Yeah. Ma'am, can you send
Yeah,
this
ma'am.
PDF?
Yeah, sure. I'll send it.
Yeah.
Okay, thank you. Can I leave?
Yes, ma'am.
Yeah.
Yeah.
Ma'am.
Okay. Bye. Yeah. Bye. I'm leaving.